Introduction. The Earth's climate has evolved over billions of years, influenced by a myriad of factors including geological activities, biological processes, and astronomical phenomena. This summary outlines 20 major milestones that have significantly shaped the Earth's climate from its formation to the present day. Formation of the Earth, 4.6 billion years ago. The Earth formed approximately 4.6 billion years ago from the solar nebula, a cloud of gas and dust left over after the formation of the Sun. The young Earth underwent a period of heavy bombardment by planetesimals, which generated immense heat. This heat, combined with radioactive decay, led to the differentiation of the Earth into a core, mantle, and crust. The early atmosphere, primarily composed of hydrogen and helium, was stripped away by solar winds, paving the way for the development of a secondary atmosphere. Formation of the Moon, 4.5 billion years ago. A Mars-sized body, Theia, collided with the early Earth, leading to the formation of the Moon. This colossal impact significantly influenced the Earth's tilt and rotation, which in turn affected climatic patterns. The Moon's gravitational influence also helped stabilize the Earth's axial tilt, contributing to the long-term stability of the climate. Late heavy bombardment, 4.1 to 3.8 billion years ago. During this period, the Earth experienced a high frequency of asteroid impacts, which had a profound effect on the climate. These impacts likely caused temporary heating and contributed to the delivery of water and other volatiles to the Earth's surface, playing a critical role in the development of the hydrosphere and atmosphere. Origin of life, 3.8 billion years ago. Life emerged in the oceans around 3.8 billion years ago, with simple prokaryotic organisms. These early life forms began to influence the Earth's climate through processes such as photosynthesis and respiration. Cyanobacteria, for example, began producing oxygen through photosynthesis, which gradually altered the composition of the atmosphere and laid the foundation for the Great Oxidation Event. Great Oxidation Event, 2.4 billion years ago. The Great Oxidation Event, GOE, marks the time when atmospheric oxygen levels rose significantly due to the photosynthetic activity of cyanobacteria. This increase in oxygen led to the formation of the ozone layer, which protected the Earth's surface from harmful ultraviolet radiation. The GOE also triggered the Huronian glaciation, one of the first major ice ages, by reducing greenhouse gases like methane in the atmosphere. Snowball Earth, 700 to 600 million years ago. The Snowball Earth hypothesis suggests that during the Cryogenian period, the Earth experienced severe glaciations where ice sheets may have covered most, if not all, of the planet's surface. This drastic climatic event was likely caused by changes in atmospheric composition and continental configurations, and it had profound impacts on the evolution of life and the global climate system. Cambrian explosion, 540 million years ago. The Cambrian explosion saw a rapid diversification of life forms in the oceans. This biological boom increased the complexity of ecosystems and biogeochemical cycles, impacting the carbon cycle and atmospheric composition. The proliferation of life during this period also contributed to the regulation of the Earth's climate through processes such as carbon sequestration. Formation of the supercontinent Pangaea, 335 million years ago. The assembly of the supercontinent Pangaea significantly altered global climatic patterns. The vast landmass disrupted ocean currents and atmospheric circulation, leading to extreme climatic conditions, including arid deserts and ice-covered poles. The breakup of Pangaea later influenced the distribution of continents and oceans, which continues to affect climate to this day. Permian-Triassic extinction, 252 million years ago. The Permian-Triassic extinction, the most severe extinction event in Earth's history, resulted in the loss of about 96% of marine species and 70% of terrestrial species. Massive volcanic eruptions in the Siberian traps released large quantities of greenhouse gases, leading to global warming, ocean acidification, and anoxic events. This event had a lasting impact on the climate and the biosphere. Cretaceous-Paleogene extinction, 66 million years ago. The Cretaceous-Paleogene extinction, marked by the impact of a large asteroid or comet, led to the extinction of the dinosaurs and many other species. The impact caused immediate climatic changes, including wildfires, a nuclear winter effect, and long-term global cooling. This event paved the way for the rise of mammals and the eventual evolution of humans. Paleocene-Eocene thermal maximum, 56 million years ago. The Paleocene-Eocene thermal maximum, PETM, was a period of rapid global warming, where temperatures rose by 5 to 8 degrees Celsius within a few thousand years. This event was likely triggered by massive releases of methane hydrates from the ocean floor. The PETM provides important insights into the effects of rapid climate change on the biosphere and global climate systems. Formation of the Himalayas, 50 million years ago. The collision of the Indian and Eurasian tectonic plates led to the formation of the Himalayan mountain range. This geological event significantly influenced global climate by altering atmospheric circulation patterns and contributing to the development of the Asian monsoon. The uplift of the Himalayas also increased weathering rates, which helped draw down atmospheric CO2 levels. Antarctic glaciation, 34 million years ago. The initiation of glaciation on Antarctica during the late Eocene to early Oligocene epochs marked a major climatic shift. The formation of the Antarctic ice sheet was driven by a combination of declining atmospheric CO2 levels and changes in ocean circulation. This event led to the establishment of a bipolar icehouse climate, characterized by the presence of large ice sheets at both poles. Formation of the Isthmus of Panama, 3 million years ago. The closure of the Isthmus of Panama altered ocean currents by separating the Atlantic and Pacific Oceans. This change intensified the Gulf Stream, leading to increased heat transport to the North Atlantic. The resultant changes in oceanic and atmospheric circulation patterns contributed to the onset of Northern Hemisphere glaciation and the establishment of the modern climate system. Pleistocene Ice Ages, 2.6 million to 11,700 years ago. The Pleistocene epoch is characterized by repeated glacial and interglacial cycles. These ice ages were driven by variations in the Earth's orbit, Milankovitch cycles, which affected the distribution of solar radiation received by the Earth. The Pleistocene glaciations had profound impacts on global climate, sea levels, and the distribution of flora and fauna. Last glacial maximum, 26,500 years ago. The last glacial maximum, LGM, was the peak of the last ice age, during which ice sheets covered large parts of North America, Europe, and Asia. Global temperatures were significantly lower, and sea levels were about 120 meters lower than today. The LGM had a major impact on human migration and the distribution of ecosystems. Holocene epoch, 11,700 years ago to present. The Holocene epoch marks the current interglacial period, characterized by a relatively stable and warm climate. This period saw the development of human civilization, agriculture, and the rise of complex societies. The stable climate of the Holocene has been crucial for the growth and sustainability of human populations. Medieval Warm Period, 900 to 1300 AD. The medieval warm period was a time of relatively warm climate in the North Atlantic region. This period saw the expansion of agriculture and the flourishing of civilizations in Europe and Asia. The climatic conditions during this period were likely influenced by solar activity and ocean circulation patterns. Little Ice Age, 1300 to 1850 AD. The Little Ice Age was a period of cooling that affected regions around the North Atlantic. This period was marked by shorter growing seasons, crop failures, and harsh winters. The cooling may have been caused by volcanic activity, reduced solar radiation, and changes in ocean circulation. The Little Ice Age had significant socioeconomic impacts, contributing to famines and population decline in some regions. Anthropocene epoch, Industrial Revolution to present. The Anthropocene epoch is a proposed geological epoch that recognizes the significant impact of human activities on the Earth's climate and ecosystems. Beginning with the Industrial Revolution, human activities such as fossil fuel burning, deforestation, and industrial agriculture have led to increased greenhouse gas emissions, global warming, and widespread environmental changes. The Anthropocene highlights the profound influence of humans on the Earth's climate and the urgent need for sustainable practices to mitigate climate change. Conclusion. The Earth's climate has undergone dramatic changes over geological timescales, driven by a combination of natural processes and, more recently, human activities. From the formation of the planet to the rise of complex life and the impacts of human civilization, each milestone has contributed to the intricate and dynamic climate system we experience today. Understanding these milestones helps us appreciate the complexity of the Earth's climate and underscores the importance of addressing contemporary climate challenges.